Hey everybody, welcome to week 12. All right, week 12, we're gonna get back into some live coding stuff this week. So just gonna kind of jump right back into it. Boot the server, push into a ProxySpace. I'm not gonna bother with a clock, I don't think, in this lecture. We're just gonna kind of focus on some other things. So make that new ProxySpace and jump inside of it. And just to recap a couple of techniques from last week. So we have any environment variable we create is automatically a node proxy. We can chain different commands together. So we're going to just play one and set its fade time to be 2. And automatically we get a little pair of monitoring nodes and a group right above. And here's a little source function I made. So we just have a cluster of 16 sine waves with different frequencies scaled back down so it's not too loud, and then spread across the stereo field with splay. And we can just, change the source to whatever we like. We could change from sine waves to triangle waves. Change the amplitude. And a couple of just basic ways of interacting with node proxies. Again, we're just recapping what we already know. Yeah, very, very spooky. So we can stop, which destroys the monitoring process, and play, and both of these accept a fade time. I think stop actually, bus plug here, this is the parent class of NodeProxy. Fade time is the first argument, so we can just do this if we wanted to. But when we play, it's not the first argument, so I'm just being consistent here. All right. Release will respect the proxy's fade time, and it fades out the source node. We can bring it back with send. And then clear will basically fade everything out, reset the proxy source to nothing, and just empty off all the nodes and groups off the server. Right? And two main things I want to talk about today. One of them is how to work with buffers. And the other one is, I think I used the word modularity, but I'm also talking about routing, mapping, and just interconnecting node proxies with each other. Okay, so normally we try to do stuff like this. So we want to make some node proxy that creates some sound that is in some way derived from a sound file on our computers. And we say buff equals buffer.read s, and then we want to drop the path. So I got some audio files here. Almglocken, prayer bowl, Tai gong. This one is metal pipe, and then a shaker. Just some sounds that we're going to work with. So normally we do something like this, and this doesn't work because we are inside of a proxy space, and buff is a node proxy, and buffer is not a valid source for a node proxy, so it gets all confused. I'm going to clear this just to be extra safe here. So this doesn't work. And it's because we're inside of a proxy space. This proxy space P is our current environment. And inside of a proxy space environment, all of the environment variables are node proxies. They can't be anything else. So if you're doing jitlib live coding stuff using the node proxy class explicitly, or if you're using its subclass ndef, in both, remember at the last week I said there are basically three approaches. There's using NodeProxy, using NDEF, or being inside of a proxy space. These are all very interrelated, very similar things. But with NodeProxy and NDEF, you've still got your regular, normal, current environment, which is just a regular environment. And so in those two cases, you can just use your environment variables like normal. This will work just fine. So this is only relevant if you're inside of a proxy space. But that said, I think the approach I'm going to show for managing buffers and lots of other things is useful regardless of your live coding approach, and also just kind of in general. And the way I like to do it is, so we say, actually, I'm also going to do buffer.freeAll just in case a buffer got loaded into memory somehow. So we can use our single character environment variables. These, A through Z, S is reserved, soft reserved for the server. Sometimes I use T for tempo clock. We're currently using P for proxy space. We only have 26, so it feels like we're going to run out really quickly. But if we just use one of them and set it equal to some kind of sophisticated collection that can hold any number and type of things, then we can get away with just having one interpreter variable. And I like to set it equal to an event, which is just, and right now E, this interpreter variable E, is just an empty event. And just as a reminder, an event is a subclass of these dictionary type classes. It's actually a subclass of environment. And it's just a space where you can store things and address them by name, compared to an array where you can store things and address them by numerical index. And event is really nice because you can just say, instead of saying e.at whatever, you can just say e dot, stuff equals, or we can just do this right now. E dot stuff. It looks like it's going to give us an error message because stuff is probably not a method for anything, but this returns nil because currently there's nothing in E named stuff. We can set this equal to 5. Right? And so now we can say e dot stuff, and that returns 5. We can say e dot things equals another event. And so then we can say e dot things dot numbers equals the array 1, 17, 3.9. And so now if we just query E, it's an event which has something called things, which is an event containing numbers, which is an array. So we can say, and it's also got something called stuff, which is just the number 5. So E dot stuff, E dot things at 1 would give us 7. E dot things dot numbers. And basically, it's just a collection that can be, any number of sub collections inside of sub collections, and so it just gives you an opportunity to organize a bunch of buffers, numbers, groups, GUI objects. You can store it all in E, and you can create a hierarchy that makes sense to you. So let's just do something more practical here, and we're going to say E.buff equals an empty event. So E is an event. Inside it, there's one thing named buff, which is also an event. And I want the first of all, I want the path where my audio files are located, which is here. So we're going to use we'll call this e.buff.path, and it's going to be equal to, just going to copy and paste this, our usual this process.now executing path approach. So there we go. We now have a thing at e.buff.path, which is an instance of path name corresponding to the folder where our audio is stored. And so now we can do our usual collect over the entries, which is something we've seen several times this semester already. I'm going to put this all in a clump here. So we take this path, and we collect over the entries in that folder using the pathname entries method, pass in the pathname instance, the 5 pathname instances in this folder, along with an index, and we're going to say e.buff at that index is equal to a buffer object. So, you know, if you're watching this after the live stream, you might want to pause and take a close look at this code. But once we run this, we can just say e.buff at 0.play. And we've done this all just, you know, using a single interpreter variable. Everything else is just sort of storage symbols inside of E. So that's there we go. We got 4 buffers, and we could, you know, if we also had like some frequency values, we could say e.freq at 0 equals, I'm just making up some stuff here. Right. And I probably freq, let's say e at freq equals an empty event like that, and e.freq at 0. See if this works. There we go. So now at e.freq at the symbol 0, we have an array of 8 random values. So we can stash whatever we want here. And I think this is a great storage approach, not just for buffers, but for everything. And it's ProxySpace friendly because we don't have to actually use any environment variables. All right, so let's clear sig just so we can start fresh here, make sure it's gone. And we'll play it again. And I'm just gonna copy in a very, very simple inside of this source function here, just a buffer related thing. Yeah, it's very, very Inception-y. Lots of, you know, things, events within events within events, goes on forever. Okay, so here, I guess we could start with just dust here. So we just generate random impulses, approximately 2 per second. I'm just arbitrarily picking the Almglocken sample. We're gonna, it's a 1-channel buffer, so I'm using multi-channel expansion to make it stereo. Play the buffer. I should be using buffer rate scale here just to compensate for sample rate mismatches, but I know for a fact that the server and these buffers are both 48,000 samples per second, so I'm just gonna do a sampling, a playback rate of 1. So every time dust generates a trigger, playbuff is gonna restart the buffer, and that trigger is also being used to trigger little percussive envelopes that have a very short attack and a 0.2 second decay, and we apply the envelope. So let's just see what it sounds like. Okay, so there's some clicks, and let's do this for a second. And the reason there's clicks is because every now and then dust will generate, it's supposed to be 2 per second, but it's, you know, it's a loose density. So every now and then you might get two triggers very close together back to back. And when that's the case, the envelope, you know, restarts and it's in the middle of its 0.2 second decay, but then another trigger comes in and causes it to jump back to the beginning, but the sound wasn't fully faded out. So, you know, we get a click. So that's why I chose to use Trig here. And so Trig is a UGen I don't think we've seen before, but it basically, when it receives a trigger, it outputs a value of 1 for this duration. So it's a way of holding a trigger for a certain amount of time so that no triggers can get in during that time. And so, you know, dust might generate 2 triggers back to back that are closer than 0.2 seconds, but Trig is just going to ignore them because it snaps to 1 when it gets a trigger, and it doesn't go back down to 0 until 0.2 seconds later. So this will guarantee we won't get any clicks. And it also means we'll never get 2 samples that are any closer to each other than 0.2 seconds. Okay, but this is pretty boring, but we could actually start doing some live coding here. You know, we're working with buffers. Let's try to make it interesting. So first thing I'm going to do is use tchoose. So take that trigger, and we're going to just get the collection of Actually, what if we say e.buff? What do we get? That is, oops. Yeah, it's not an array, so I'm going to do it this way. We're going to collect over the array 0, 1, 2, 3, and just take, and just return an array of those buffers. So now it'll, every time we get a trigger, in addition to what we're already hearing, we're also going to hear a random bell buffer. I'm omitting the shaker. I mean, we could include it later, I guess, but. Okay, so random samples, that's a start. Let's make an 8-channel trigger signal, and we'll splay these. Did that work? No, I messed something up. I need a semicolon. Forgot my semicolon on line 60. And we could slow these down a little bit. So now we have 8 unique random trigger signals. And so we have all of that multi-channel expansion propagates through. Oh, I should probably get rid of that, I think. Let's make 12. Okay, so it likes that. Now it's a little bit more interesting. And let's make a variable called release. And it's gonna be let's be 0.2 to 2. And we are gonna drop that in here. So the triggers will randomly hold themselves open for some amount of time, all 12 of them. And we're gonna also put that in for the envelopes release. So now some of them will be really long, some of them will be really short. Yeah. And just, you know, because we're in a proxy space, we don't have to like stop and play and set and do it. We just, you know, just change our function as we go, and it's pretty good. And then let's also do the rate, right? It's pretty obvious that we're just playing 4 of the same samples over and over again. So let's say rate t choose -12 ... 12 MIDI ratio, and we'll put that in here. A little higher, a little lower. This is why I didn't bother with a clock, because I'm just gonna do this cloudy, you know, wind chimes thing, so I think that's a little too low. Okay. Yeah, so I think that's sounding kind of nice. Let's say, let's go ahead and release it just for a moment. So that's a cool sound source we can sort of work with. Let's, just to show you another angle of working with buffer related sounds in a proxy space. Let's just make another one here. And let's set it equal to we'll play the shaker, and we'll lower the rate a little bit just for fun. Now, normally, we are accustomed to putting done action 2 here because, you know, we're playing a sound file once, and we don't want to get careless, so we actually want to make sure that it frees itself when it's done. But that's not how node proxies work, right? You can be pretty lazy about done action 2. Like, here we go. Right. And this, I think it's like 3 seconds long. It's going to be a little slower. But, you know, it's done. It got to the end. It doesn't loop because I didn't say loop 1. You know, I didn't put loop 1 here. If I did, it would have kept looping. And it gets to the end, and there's no done action 2. But it doesn't matter because we just, you know, we want to play it again at a different rate. We just change that, and just run it. See, and it just faded out it faded out the old one, which was already silent. It was at the end of the buffer. You know, you can just kind of little stereo thing happening here. I wonder what happens if you do put down action 2 here. Kind of curious. Yeah, I guess nothing, right? I mean, well, compare. Yeah, so without done action 2, the thing stays here, but it just doesn't matter because NodeProxys add this extra layer of, you know, a thing that is keeping a reference to where the synth would go on the server, and it's kind of always keeping track of that. So I don't know, just again, it's a different way of working. Let's clear sig 2. Let's bring back sig. Yeah, still there. All right. Now that we have some sound that we're working with, I think we're ready to talk about modularity, routing, mapping, interconnecting. So a big question that comes up in GitLib stuff is like, how do I do effects? How do I route one node proxy into one or more effects? How do I chain effects in series? How do I do effects in parallel? You know, how do I like mix several proxies together and, you know, that kind of stuff. Inserts, sends. And I think I've got a pretty good grasp on this. It's pretty intuitive. Just because we're in a new section here, I'm going to clear this and actually copy and paste this stuff. Okay, so just making sure it still works. Okay, so it's going, right? Gonna turn it down a little bit so I can hear myself think. So we want to put like a reverb effect on this, right? No problem. So we'll just make a reverb effect here. And the question is what goes, you know, what's the input here? So what I'm going to put here is in.ar 0. And it's a lot like, you know, adding an argument. You know, when we say something like, you know, something like this, right? It's just it's basically a control UGen running at a certain rate, in this case, KR, which has a default value of 440 and it has a name freak. So we're doing the same thing here. Gverb has an input here. It's an audio rate signal called in, which has a default value of 0, so it's just silence. We'll just fill in the rest here. Low pass filter. Do one of those, and we'll just run it. And so it's playing. You can see it says verb right here. It's just that nothing's plugged into it right now. And so, check my notes, make sure I don't mess this up here. We can use the NodeProxy method map. We say verb.map in sig. It's really easy. So there's going to be a pop here. Or maybe not. Thought there was going to be a pop there. I guess it's somehow using the reverb's fade time. So look at that. We got reverb, and now we have 2 node proxies. We can bring up the wet a little bit. Pass some more high frequencies, so it'll get more sizzly. Very nice, right? We can disconnect with unmap, like this. I was definitely messing with this earlier, and I got a pop here, which is why I was going to show xmap. And this one will definitely crossfade. And as far as I know, there is no un-xmap or x-unmap or anything. I don't think so. But you can just say x.map in 0. And that will just map a value of 0 into this input here. All right, lovely. Let's make a delay effect. Yeah, it is neat. It's awesome. All right, we're gonna copy this just to make things easy for ourselves. I'm gonna put these in the same clump. And we're gonna say comb in 1. I think this determines the crossfade length. The fade time of the node proxy, I think. I don't know what else it could be. Okay, let's make this a little bit more mellow. Not quite so much high frequency. Alright, run that. And then we want to say del.xmap in Trig. And there's our delay. Let's say so now delay only, no reverb. And we can say map the delay to the input of the reverb. And this, I love it. I mean, it's just great. It's just so intuitive. And this is just one of 2 ways that I know of that you can interconnect these. Yeah, party face, for sure. I think if we stop sig, we should get only the reverb. Because sig is still stop. What does stop do? Stop takes away the monitoring process. So it's still, the source is still there, and the routing is preserved. I think if we say del.xmap, that should stop everything. But then we can say verb.xmap in sig. Now we have just the wet reverb. It's so dynamic, right? You just decide what goes where, and you plug it in, and you can just start with a nothing signal, and then just route as your heart desires, right? Let's see if we can sig.play. Let's do another quick routing example here. I'm just going to make another proxy. I'm not going to play it. It's going to be a control rate proxy, slow sine wave. It's going to be used to control the delay time of this thing here. So I'm going to change this to comb L because it's now a dynamic delay line, and we want to interpolate. We just plug this in here. I think we can say, well, to follow our paradigm here, in del time, which will be, I don't know, 0.3 by default. And I think it's actually harmless to actually play it again. Doesn't matter. We just run the whole thing. Right, and then we're going to say del.xmap indel time LFO. Do that, and let's go grab our signal from here. Yeah, it's just so liberating just being able to make decisions on the fly. I think it's fantastic. So we're just gonna run all of this through a resonant low-pass filter. Let's start it at, I don't know, 1500. So this should be fine. And then we're gonna say sig.xmap filt LFO2. And there's our low-pass filter effect. Down here. Yeah, there is sort of a abrupt change when we just suddenly restart the sine wave here, but I think that's fine. Oh, you know what? It's only happening in the left here, and I overlooked something here. And it's probably a multi-channel expansion thing somewhere. Let's do why would delay? Do I have to specify? Well, I'll tell you what. I think I must have. Let me just maybe come back to this, and I want to show the other way of interrouting these, which I think is even better. So all right, so we'll just reset all of that. And there it goes. So there's another way to do the same thing, slightly different syntax. And let me just grab some things here. So grab this. All right, we got this sound here. And let's grab our reverb as well. All right, so instead of doing this, we're just gonna say, I don't know, you could put anything here. Silent.ar. It doesn't have to be, you know, just want to start it out so it's actually not processing anything. And here's what I think is great. You just drop sig in here. It's gonna give us a channel problem here, I think. It's gonna work though. It works, but we get synth output should be a flat array, wrapped from 4 to 2 channels. The reason we're getting this here is because Gverb expects a monophonic input and output stereo, and sig is outputting a stereo signal. So what we need to say is something like, we could just say sig.ar and then the number of channels here. When we can reference a NodeProxy object by its name, give it a rate, and then we can say how many channels, which channel to start at, and what to do if you, I'm not exactly sure what clip is, but this will give us no error messages. So it's only feeding the left channel, the lowest numbered channel in. All right, so let's do the delay while we're here. I want to also put the signal into the delay, so we can just put it in like this, I think. And 2 channels here, I think is what makes sense. Set this to be 0.3. For me, I think this is even better, because you're literally just plugging them in here, and you know what I can say is let's put the delay signal here instead, and so it dynamically reroutes everything. So signal is going into the delay, and then the delay is going into the reverb. Let's see. No, we don't want to play it. We just want to create a source. So there's that. And I think then we do this. Yeah. You can also, let's tone this down a little bit. Let's see. We can also add node proxies together. So right now we got the sig going into the delay. And what we can do here is we can say, right, just let's pass some of the sig straight into the reverb, but also pass it through the delay first. Not really possible to hear a difference here. I mean, it sounds pretty much the same, but we do have we have this, the source signal going straight to the reverb, but also going to a delay modulated by an LFO, and the output of that is going into the reverb. Yeah. And it's just, you know, just such a fluid experience, I think. Could even just do this. I bet we could lag this. I think this will work. So now when we change this, it should smoothly, somewhat smoothly. I guess we could do var lag. Make it longer and linear. No, I think I messed something up. Curvature. This might not be possible. Alright. Let's go ahead and... It's out of control! All node proxies have a volume attribute, I think. I don't know if it's possible to lag this value. It might just be a hard set. It's kind of just a convenience. We still have the reverb though, right? Just because you zero these out doesn't mean they're still not interconnected. I think this controls the monitoring, the volume of the monitoring process. Let's bring it back up. Let's see if we can find a nice way to fade this all out. You know, maybe something sort of musically interesting. Cool. All right, I think there's one more thing I wanted to share with you, and that is using set, right? We know set from synth, synth.set, set this, set that. You can do that with NodeProxys too, at least if their sources are, well, maybe even if there are their p-binds, it might be possible to set. I don't know. The more I learn about this, the more I'm just like, oh man, this rabbit hole goes straight to the center of the earth, doesn't it? It is wild stuff. Okay, set and x set. All right, so let's go back to a semi-simple example here. I'm just gonna wipe everything off. What are those doing there? Oh, there they go. Okay. So this is similar to the very first example. So I have a Detune Control. So this is a control rate argument, right? It's got a default value of 1. This is a noise generator. There's 16 unique channels ranging from positive to negative detune, converted to MIDI ratio. So basically this is a value in semitones in either direction. And then we have a frequency, which is 200, multiplied by this frequency deviation signal, scaled down, all 16 channels spread over stereo. Yeah, and so if you have created, you know, an argument, it's not really an argument, it's a control unit generator, whatever you want to call it, one of these things, then you can set it. Okay, and here's the twist. If I change this, it looks like it's going to reset back to 200 if I run this code, but it won't. It remembers the, you know, what value has been mapped onto this control. So it'll all change to triangle waves, but the frequency will still be the current 300 hertz. Right? So it's all it remembers. It remembers the argument values, right? You can also set the detune to be wider. All right. There's also X set, crossfade set. And this doesn't interpolate like lag. What it actually does is it fades out the current one and fades in a new one with the updated parameter. Oh, and that's right, that's a set, so we'll do it like this. It sounds like bees. I think 28 is my favorite MIDI note number. You just know it's gonna sound good every time. I don't even know what pitch it is. I just know I like 28. All right, so that's set and X set. Remember what I was gonna do. Oh, okay. So yeah, if you actually want to, you know, instead of crossfading one out and bring another one in, you know, you can lag. I know this will work for sure. Well, I would say for sure, but you know, let's make it a 2-second lag time, slightly exponential. And so this, I think it'll keep it'll keep 28 MIDI CPS for sure. That seems good. And so now when we set to a new value, it'll be lagged. Right, 2 seconds. Detune will not lag because we didn't lag it, but we could. All right, the cloud of bees is spreading. All right. Yeah, so if you lag a parameter and then do xset, it won't do the glissando thing, because what it's actually doing is fading out the current one and fading in a new one with the new parameter. And so it's just gonna, even though it's lagged, a new one is coming in with the value you specify. So if we do something like, you know, something like this, it's just kind of a regular crossfade. So xset and set, you know, if you lag something and you want to actually hear the lag time, you should use set. But if you haven't lagged your parameters and you want to do a smooth fade, xset is good because it'll fade one out and bring the other back in. Whew, live coding is fun. It is fun to do some live coding stuff. I think that's all I have prepared for today. So working with buffers, with this elegant sort of event type collection, being able to put any number of things in any sort of hierarchy, and then you can load buffers in and start making NodeProxy source functions with playBuff and buffRead and stuff like that, grainbuff, tgrains, whatever you like. Routing, mapping, interconnecting. What this reminds me of, sort of just plugging things in where you want them to go, like you know, this style here. What it reminds me of is like an analog modular synthesizer, where it's like you just have modules. Like each node proxy is a little module. It does a certain thing, makes a certain signal, and you can just, you know, grab a virtual patch cord and just stick it into any old effect, use it as a modulating signal for anything else. It's a little bit more dangerous in SuperCollider because, you know, numbers can be really large in places where they're supposed to be really small. Whereas on an analog synthesizer, there's kind of a standardization of voltages where you can't really blow anything up, at least not very easily. So you do have to be a little careful. But I think just this is the basic way that I like to do it, is you just make node proxies and you give them names in a proxy space and then just, you know, route them in a very intuitive way. And then being able to set parameters is nice. There's lots more to talk about, and there's lots more that I don't know very well and I'm not really prepared to talk about. But I do think the NodeProxy help file is long and a good read. It's just, you might even want to skip some of the stuff and just look at some of the examples. But there's a bunch of sections, listening to the output, embedding and combining the proxy. There's a couple of weird, funky, sometimes convenient syntax shortcuts, like this arrow thing and this This is the chain operator, sort of the function composition operator, which I think we talked about at some point with regard to patterns. Yeah, I think at the end of the intermediate patterns lecture. So it works here for node proxies as well in a kind of different way. Routing, which is the stuff I talked about here. Just kind of goes on and on. Oh, reshaping is cool too. It's just you can make it a dynamic number of channels, which is something you really can't do outside of the live coding framework. And blah, 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 blah. And I think there's like a long bit of examples at the end. Yeah, sort of right at the bottom of NodeProxy, examples. And you might just go here and just run them one by one and study them. And just keep in mind that even though these examples are using NodeProxy, all of the methods and operations apply if you're inside of a proxy space. Just the syntax is just a little bit different. And then I guess one final thing. I got a couple of questions about this. I'm not putting forward the GitLib live coding stuff as a necessarily superior alternative to using SuperCollider in the more conventional way with synth-def and synth stuff like that. It's a different way of working. It's not necessarily a better way of working. And so you might find yourself asking, okay, if I want to do this very, very specific thing with this very, very specific combination of things, how would I do that with NodeProxy? And the answer is well, if you have a very, very specific thing already planned, I don't think GitLib is going to give you any tangible advantages. I think it's just kind of GitLib is really nice if you like thinking on your feet and you don't quite know what you're going to do as you're doing it. Just kind of feeling it out as you go. I think that's when GitLib is really nice because it's a very fluid experience. But if you have really specific plans where specific things are supposed to happen at specific times, I don't think you're necessarily going to find that task any easier if you're using NodeProxy. That's all. All right, so I hope that was fun. Hope that was entertaining and educational. Give it a try. Do some live coding. I'd love to see what some of you come up with. Next week, we're going to talk about pen and user view and making some elementary graphics and animations in SuperCollider. Maybe we'll try to cook up a very basic audio reactive thing where we have a sound and the visuals kind of respond to it in some way. It should be fun. And then I'll probably be in touch with some of you, my Illinois students, about your final projects, just seeing where you are. And if any of you have questions that you think might take a while to answer, I'd love to hear them. And maybe we can kind of put them on stream for the very last day of class 2 weeks from now, as your final projects are shaping up. So that's it. All right. Thanks, everybody, for watching. And see you here next week, same time.